This question is from GATE 2012 Mechanical Engineering paper, question number 20. In the mechanism given below, if the angular velocity of the eccentric circular disc, this disc which is eccentrically pivoted at this point, is 1 radians per second, the angular velocity in radians per second of the follower link for the instant shown in the figure is. We need to find the angular velocity of this follower link. Let it be omega f. Angular velocity of disk omega d is given as 1 radian per second. These distances are given as in the figure. Let's see how the angular velocity of follower link will be found out. Let's start by naming some of the points here. Let this point be A, this be B, center of the circle be C, the other pivot point be D, and let's connect B and C. Now we know that this is a right angle as the link is tangential. Angle between them should be 90 degree. This is the center of the circle C, hence this will be the radius. This is 25. Now we see that in triangle ABC, we have AC is known. AC is 45 plus 5, which is 50 millimeters. BC is also known, 25 millimeters, radius of the disc. Hence we can find out AB because this is a right angle triangle. AB will be equal to root over hypotenuse square, that is AC square, minus BC square. This will give us AB is equal to under root 50 square minus 25 square. In the digital calculator, by calculating this, we have 43.3 millimeters. So we have got length of AB as 43.3 millimeters. Now we need to find out the angular velocity of AB. If we manage to find the velocity of B in this direction, that is radially outward, VB, we can find out omega F, which is the angular velocity of the follower link, by taking omega F is equal to velocity of point B, VB, divided by distance of B from pivot point, that is AB. So if we manage to find out VB, we'll be able to find out omega F also. Now to find VB, we can use this angular velocity of the disk, omega D, by calculating the perpendicular distance of point B from the pivot point D. So this distance can give us VB because this perpendicular distance into omega D will be VB. Hence we can write VB is nothing but the perpendicular distance, let this be small d into omega D. Now how to find small d? If we connect point D, drop a perpendicular to BC, we have this smaller triangle with a side DC, and let's name this point to be E. So we have a smaller triangle DEC. In triangle DEC, DE is nothing but small d, the perpendicular distance. We know DC, but we don't know EC to find out DE. We'll therefore use the similar triangles, that is triangle ABC will be similar to triangle DEC because we have both as right angle triangles. So angle B is equal to angle E, right angles, and angle C is the common angle. So a similarity test gives us that these two triangles are similar. Therefore their corresponding sides will be proportional. We can write AB upon DE is equal to AC upon DC, only in the terms of the known values. Therefore we have DE equal to, DE will be AB into DC, AB that is 43.3 into DC that is 5. So 43.3 into 5 divided by AC. AC is nothing but 50. So we have DE here. DE will be equal to 4.33 millimeters. So this perpendicular distance is known now. Omega D is also known, 1 radian per second. We can find out VB from here. Vb will be equal to 4.33 into 1, simply 4.33 meter per second. Now using this Vb, we can find out omega f. We already wrote the formula here. Omega f is Vb by Ab. So omega f is equal to 4.33 Vb divided by distance AB is 43.3. We have this answer as 1 by 10, which is 0.1 radian per second. So we finally have value of omega f to be 0.1 radians per second. Let's go back and mark the correct option. Angular velocity of the follower link is 0.1 radians per second. To learn more about velocity analyses in such mechanisms, you can refer to the NPTEL video Lecture 27 Velocity Analyses Examples from the course Kinematics of Mechanisms and Machines. This course is by Professor Anirvan Dasgupta. He is from Department of Mechanical Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.